Okay, here it's Garnet. Let's call it part two. I'm in a little bit of a rambling mood today, so I apologize for that. It's just that I've been thinking more about it and wanting to at least present some conversation so that you have a better, at least attitude, maybe not so much knowledge, but better attitude towards this thing called brain entrainment and how it would be the same or not the same, or how it compares to the Neurolite design, a process that I'm labeling brain engagement and not just brain entrainment. Okay, brain entrainment. Everybody, there's been a renaissance in these past roughly 5 years with brain entrainment, I think for maybe 2 or 3 interrelated reasons. Number one, computer technology has just exploded since 30 years ago. If I look back at the very first Apple computer that I bought and how I was so disappointed because I couldn't get this thing to work and it was so slow, but the promise. But now it's extraordinary. So I think computer technology, where you can get all kinds of software programs and have the ability to be creatively inventive and make up all kinds of sound things, and you can do beats and binaural beats and music, and it's we could never do that before, believe me. The second thing I think is social media and the way that everybody wants to share, beyond selfies, please. Everybody wants to share in this process, and that's fascinating, and it makes things available that weren't available before. And then I think the third thing is kind of a recycling of interest, maybe as a counter-reaction to technology in nature and consciousness. I think there are a lot of people, I'm older, I would think maybe a lot of younger people that have some disappointment in the big promise of society, so there's an interest in consciousness and spirituality and hallucinogens again and so on. So I think these things are brought forward again to a new group of people that may not have a sensitive experience or awareness of what happened, 50 years ago or so. So, binaural beats, I mentioned briefly. It's a way of trick the brain into sensing something when it's hearing two different things. It hears the difference. Here's a really peculiar thing about it, because you can describe, based on a lot of neurology, how the pathway goes in and plays the trick, how it involves, the brain stem and lower brain, then midbrain, and then up and so on. The funny thing about it is that you have to use headphones, you have to isolate, and that there's another kind of headphone that nobody uses, but technically you can make them, where the sound is conveyed through air pressure, not the electromagnetics that are in all the headphones. And when you look at the EEGs of people using the typical headphone, the electromagnetic delivery of the signal, you see all of the EEG reactions, where it's getting coaxed and some parts of the brain will want to entrain to the signal, the false signal, the third one, right? Because number 1, number 2 makes number 3. The funny thing is that if you use headphones and do exactly the same thing, but these headphones are air conduction headphones, you don't see the EEG activity. Say, well, wow, wait a minute, it's the same signal going in. The eardrum is pulsing in the same way. So there are some people that theorize that the whole binaural phenomena may be, in fact, electromagnetic induction more than a sound wave being processed through the auditory. So I just thought I'd mention that because, it's easy to get charmed into an idea, and especially when the idea can be popularized and even fantasized so that it's really attractive, that you just grab onto it and hold on to it. So this thing about brain entrainment and binaural beats, because there are also monaurals, where you have double on both sides. You have isochronics where you don't need headphones. And you have these things called harmonic boxes, and it goes on and on. There are lots of ways to do this. The trick is, and maybe this is not repetitive as much as the summary of part 2, is that brain entrainment, conventional or standard or traditional brain entrainment, can create a neurological effect which is measurable using EEGs or quantitative EEGs. You can see a lot of what's going on in the cortex, and you can kind of hold it there for a period of time and also have subjective states associated with it. But it's only an aspect of the brain activity. It's only an aspect. You know, it's like if you've got a sensor that only detects the color blue, and you go off into the forest, well, you're going to find blue, but you think, well, there's not much color here because look, there's not much blue. It's because you don't have an instrument that looks for red and green and yellow and orange, because it's only calibrated for blue. Rough analogy, but if you're only able to detect certain aspects of the brain's function, and of those aspects only parts of those aspects, meaning mostly the cortex and not the deep inside brain or the old brain, the stem and midbrain and so on, we have to be careful to not jump to too many conclusions. You know, there are 4 basic, and this is, I guess, the lead for, I guess, what will be part 3. There have been 4 basic ways that we've been gathering information about this topic. The first was, you know, going back to the 20s, but it really matured after World War II in the 50s, EEGs, the ability to stick stuff on the head and measure activities. Well, one thing to understand is that you're not getting much more than the cortex. It's okay, because the cortex is so important. The other is that the spaces between the nodes pick up signals, and most all of the software interpretation averages. It makes an average. So you can have 40 here and 20 here. If those are the only two, it will average out to 30 in a simple concept, if you know what I mean. So we began to be able to stick things on the head and use entrainment to see what the hell is happening. Because before that we could see what was going on, but we had no way of eliciting it. You know, digitally, or analog and then digitally controlled stroboscopics didn't really come out until after World War II. And so it's in the 50s and into the 60s that we were able to go, you know, flash, 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 or beat, 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 and see what's happening in the brain. So we were able to create phenomena in the brain, measure it, and then ask the person, hey, what does that feel like? And they say, well, I feel calm, or I feel drowsy, or I feel memories, or I feel, you know, whatever, all the different kind of subjective category reports. So the first thing was getting the brain to get excited in a certain way by stimulating it, and then asking the person, hey, what did that feel like? And yeah, sure enough, that, you know, alpha is calm and clear, and theta is kind of a memory, dreamy state, and, you know, on and on and on. And so there was that. And then, and it's been happening recently again because of, again, cross-cultural things, where we get people that know how to go into a certain state subjectively, and they can report those states. These are the famous Tibetan monks and Franciscan nuns and so on. So they go into these states, because they also do it with pathologies, you know, schizophrenics and neurotics and epileptics and so on. And they say, okay, I'm in this state now, and they measure the brain, and they say, oh, now we get to see the correlation of the brain waves with this state. So the first one was get the signals and ask them what they're experiencing. The second one is get them to experience it, and then we get to see what those signals are like. So it's like 2 different ways in the same relationship. The third thing, which has been rapidly evolving, is brain imaging, where we can see mostly, you know, there are PET scans and so on, but the ones that are used the most are the functional MRIs. They make the beautiful images. And we get to see areas lighting up in real time when we get to image things or have them in subjective states. So that's the third one, is medical imaging. So first one is get signals, ask the state. The second one is create a state, measure the signal. The third one is brain imaging, where we can see things that are only imaginations before, could never see inside. And the fourth one, which has been ongoing, is the extraordinary research done mostly around trauma and brain surgeries, where neurosurgeons will literally be in the physical brain and doing certain mappings as to what happens. You know, oh, I do this, I remember, I do this, my left foot moves, I do this, and I see kaleidoscopic images. So these four things are now joined by a fifth general principle. And this is the principle of neuroplasticity. The fact that the brain is eagerly attempting to adapt all the time, and this ability throughout the entire age spectrum of a person, obviously most potent in the early stages of youth, maturing at around the mid-20s, but still continuously adaptive throughout the rest of our life to different degrees. This neuroplasticity now makes the fifth huge category, and maybe I could say sixth, because neurochemistry has been better understood all the time with neurotransmitters and neuropeptides. I guess the point I'm making is that learning how to signal the brain to message the mind from 1973, 83, 93, 2003, 2013, 17, 45, from the basic theories that came out with brain entrainment almost 50 years ago. So much has happened in the past 20, 30 years, since the late 80s and early 90s until now, that it offers us, I believe, a whole new perspective on how to interact with the brain using signals. And I think brain entrainment is an important but limited aspect of brain signaling. And what we know now that we didn't know before affects this to a great degree. So let's call that part 2, comparing brain entrainment and brain engagement. Thanks.